couple new things on Google today, which I'll show you in a second. After I get set up here. How's it going?
What are you looking for, Christian? Okay.
Yes. Open all of them. Open all. We're opening all the windows because you know it's stale, and also this is a pandemic, and the windows are staying open. Okay.
Fresh air is a good thing.
As the weather gets colder, dress warmer. Because the windows will be staying open even when it's chilly. So keep sweatshirts, maybe switch to pants, put some socks on, windows stay open. Okay, so today is the 19th. Since there are some of us that are home, as you can see in this class, but also in plenty of the other classes, I'm telling you this too in case at some point you will be home. So if you're a quarantining student, there is a link, which I'll show you in a second, posted under the classwork tab. You'll click on videos of lessons, and then there'll be all my streamed lessons there for you to access. So if you want to re-watch a lesson from a different date, it's there. If you want to see what we're going over that day, it's right there too. Okay, so I'm going to show you once you copy down your homework. So today in lecture, we're only going to go over the tests. I'm going to go over some questions that I thought were difficult, but I'm also going to then give you the opportunity to ask me questions to go over. My tests are not cumulative per se, but the Regents is. So although the material that was on this past test won't be covered in the next test, it will be covered in June should you have a Regents exam. So it's not like it just should disappear from your brain. So there are things that if you didn't understand, we want to make sure that you do understand them by the end of this class today. Then we'll do a little introduction to astronomy PowerPoint, which is really just cool pictures of galaxies, and we'll go over some of the stuff that you'll be talking about in the next couple weeks. And then your homework, and we'll probably do some of this in class too. Clear out your binders. So you may have done this over the weekend, you may not have. I'm going to give you an opportunity in class to do this today. Your binders are filled with all the materials. We're going to start a new lab, the topography of Lake Ontario. We'll talk about if we can go outside once we get into lab. I think we should, but we'll kind of pay attention to the weather, if it's wet out there, and then just make sure overall that people have the time that they need to spend outside, and it won't be just a waste of time. Okay? Homework for lab is to make sure you finish the goals we talk about in lab. And then if there's anything that has to go on Google, make sure it's getting on Google, especially the labs. Okay, so let me just show you. So if you want to access my YouTube videos, go to classwork. Hopefully this works. There we go, good. And so here you see videos of lessons as a tab, but let me zoom out a second. So over here on the left, as long as you're zoomed out in your browser, this should pop up on the left-hand side. You'll see topics. As we go through the year, the topics will increase. So right now we've only covered one unit, Intro to Earth Science, so this is Unit 1. I'm going to start putting up astronomy stuff too. You're going to come to my YouTube channel, okay? So if you click this, it'll pop up. You can click this link, and then it should bring you to my YouTube page where you can find the video. Okay, so here's the videos from the previous weeks. And it gives the date. If we have lab that day, it'll have 2 videos, or it might just have 1, depending on if we kind of go into lab, or maybe lab is a little bit more separate. It kind of depends. So just look at the date. And I'll also be a little bit more specific about what topics we're covering that day in the description as well. So if you're out and you want to stay up to date, am I going to hound you and make sure you do this? No, but you have the option, okay, to keep up with what we're doing in class if you're out for an extended period of time. Okay, so again, in Google, it's under classwork, and it should put up the actual test up here.
We just have one question.
Yeah. What'd you say? Yeah, go ahead. So let's see. Overall, people did pretty well on the test. I'm gonna call you up. So when I call your name, if I say, you could just come up and grab your test. 'Cause I don't think you're Colston. Megan's not here. David's not here. Brody. Dylan is on. Carolyn. Giancarlo. Christian, you're right here. Ava. Sam. Lily. Oh, Sarah. And Cole. And then Madison's not here. Angeline, you want to take the test? You will just need your reference table, a pencil, and a ruler if you want one. And Madison's not here today.
Interruption. Please send Christian Meadows to the office for dismissal.
Yep, no problem.
Thank you.
Okay, so take a look through your test. You've had a second to kind of glance at it. Just make sure that your brain makes sense. Look through all the questions. It's possible I made a mistake. The point values are roughly 3 points. You just don't know the test. I did try to give partial credit where it was appropriate. So, for example, the profile, or connecting the ISO lines, things that required multiple steps. I tried to be a little generous there. On the regions, they will not be. They won't be so generous. You're going to have to get it all right or nothing, which kind of stinks. Okay, so that's what makes some of the questions more difficult. So just take a look at it. I'm not going to go over the entire test because I just don't know that that's super helpful. We would all be very bored. But I will take some time and go over the questions I thought people had trouble with, and then also give you an opportunity to ask me if you want to go over certain questions. Yes, Sarah. Yes. Okay. So let's see if this works. It didn't work first period. Oh. Woo. Okay. Nice. All right. So first questions. Let me get organized here. Okay, if you want, I can take a look at your test toward the end, like when we're done, and I can calculate your grade again and see. Okay. Right, so question number 1, I saw people have trouble with. 1 and 2, actually, which is kind of crazy. So I just want to draw your attention to the reference table again. So if you didn't get these questions right, I'm just going to show you where to find them in the reference table so that you can easily find them again in the future. So question 1 and 2 came straight from the bottom of page 1 of the reference table. Okay, so this talks about the elements of the Earth as well as their in the crust, the hydrosphere, and the troposphere. So question number 1 said, what is the approximate percent by volume of oxygen present in the troposphere? So you would just find troposphere Oxygen, this is percent by volume, that's the only column, and it's 21%. So right from the reference table. Question number 2, the approximate percent by volume of aluminum in the Earth's crust. This one's a little bit harder because you have 2 columns, okay? So the Earth's crust is here, and they want you to find aluminum. So here's aluminum, and they want percent by volume. So that's 0.48%, or 0.48%, not 8.23. So a lot of people picked B because they did this one nice and quick because that's the first one that you'd see next to aluminum. But make sure you're paying attention to percent by volume versus mass. Okay? So again, answers are there, but sometimes it's tricky to find the answer because the reference table is not always the easiest thing to use. Okay. Question number 10 was another one that I saw people get wrong. So question 10 says, how are latitude and longitude lines drawn on a globe of Earth? Okay, so if you remember from your notes, if you're looking at a globe, latitude lines are doing this. They're kind of going in circles around the Earth. They never touch, they're parallel. And the longitude lines are kind of like if you peel the skin off of an orange and you take slices of the orange out, or maybe think of a beach ball, the longitude lines meet at the north and south poles. And so the correct answer for this one was C. And this was an example that's right in your notes. Okay, something that you really couldn't use the reference table for this, but you had to study and know. Okay. So that was it for the first page. Is there any other questions on the first page that, before we flip to page 2, you'd like me to stop and go over? Because I'm happy to. Okay, now is the time to ask. Sure? If I gave you this test back again, you'd all get hundreds. You'd be like, oh, yeah, I see where I got wrong. Positive. Don't feel pressured. Take a look. Look at the questions. Could you get 100 again if I gave you this test? If you couldn't, this is the questions you need to ask.
Good learning opportunity.
Yeah.
Don't be shy, please.
Because remember, there's no extra help. So this is like, I'm trying to make sure before we move on to the next topic, all of this makes sense. Once. Twice. Okay, page 2. And I can always go back again, even though I counted down, I will still go back. Okay, so starting with number 12. So on page 2, 12 was okay. Let's look at 15. 15 was one I saw people get wrong. The graphs always freak people out. So we'll talk about this a little bit. So 15 says, which graph best represents the altitude of Polaris observed at northern latitude positions on Earth's surface? So the altitude of Polaris, you have to remember, is equal to the latitude of the observer. So they're literally the same number. Whatever the altitude is, the latitude is. So if the altitude is 0, the latitude is 0. If the altitude is 10, the latitude is 10. They're equal to one another. So you needed to pick the graph that said that at any point they're equal to one another. So for example, let's look at number 1. So just using the graph, they have 0 and 90 written on here. So let's start with this first one. So when the latitude is 0, the altitude of Polaris is 90. That already doesn't agree with my rule. Okay, and I can do that at any point on the graph. Let's say I'll go right in the middle. Halfway between 0 and 90 is 45. So let's say the latitude of the observer is 45. Okay, the altitude would be 45. Okay, so that one agrees. That one checks out. Now let's look at 90 again. So latitude is 90. The altitude is 90. So that doesn't work for this point and this point. So 1 is not 2. So 2 says, when the latitude is 0, the altitude is 0. That checks out. That's good. And going like at about 45 here. When the latitude is 45, the altitude is 45. That checks out. When the latitude is 90, the altitude is 90. That checks out, which is why 2 is your correct answer. And you can do that with 3 and 4 as well. They should be equal at every point on the graph. Okay. Let's see. Anything else? Let's do 16. Time zones were always a tricky question for people, especially when you're not given a nice map. So 16 says, it's 5 p.m. on the prime meridian, which we know is 0 degrees longitude, and you are at 60 degrees west. What is the time? Okay? So prime meridian is 0, 60 degrees west. So if I want to go west, I have to go this way. As we go west, remember west time is less. And so prime meridian is 5 p.m. So I need to know what time is it at 60 degrees west. That's the question I'm asking. So the first thing I need to figure out is what is the degree difference between 0 and 60? And since one of the numbers is 0, we know the degree difference is 60 degrees. Now we need a magic number. Does anyone know what magic number I'm talking about? Ooh, 2 hands right up. What magic number do I need to answer this question? Without this number, I would have no hope of solving it. Giancarlo? 15. What is the significance of the number 15?
That's how wide each time zone is.
Yeah, exactly. Each time zone is 15 degrees wide. 15 degrees is equal to 1 hour of time. So if we do 60 divided by 15, we can figure out how many hours is in between. So that's 4 hours. So we know that if this is 5 o'clock, 5 p.m., our time should be less by 4 hours. And so now we can figure this out. 5, 4, 3, 2, 1 o'clock. Okay, so now I'm left with a.m. and p.m. If this is 5 p.m. and we need to go earlier, it would be 1 p.m., not 1 a.m., because this is 5 p.m. A 4-hour difference from 5 p.m. is not 1 a.m. That's much more than 4 hours. Okay, so tricky, number 16. So that's kind of it for me for this page. But is there any questions on this page you'd like me to go over? Any that were difficult using the reference table, like in 13 and 14? Maybe figuring out density from the graph in number 17? Good. Going once. Twice. Okay. Yeah, quiet. First period had a lot of questions. It's funny, some classes ask like endless questions and some just don't. So 19 and 20, I saw people get wrong quite a bit. And these were really questions that you just needed to know. These are in your notes. So I probably would have just studied these questions. They're also, they're in homework number 1 for, I think, the 2nd chapter. So the Earth slightly bulges at the equator because it's rotating on its axis. The spinning motion causes the Earth to slightly bulge around the middle, which is why the Earth is not a perfect sphere. It's called an oblate spheroid, which is choice C. So these questions are related to one another. And that, again, was right from your notes and from a homework assignment that you had. Okay. So I'm going to go over the Part B questions, pretty much all of them. Because in general, the multiple choice students are good with. It's the Part 2 questions where you have to come up with your own answers or write on diagrams that more often than not students get these wrong. So we'll take our time going over these. Okay, so 21 says on the grid in your answer sheet, construct a topographic profile of the lands along line AB. So this is where you're drawing your profile, A to B. And so I'm going to give you a general idea of what this should look like. So just check with yours. So the dot should start at 340, and it should end at 29. So that was the first and last point that you should have plotted. And then your line's just going to kind of go down. And so you should have dots that kind of go down in a row, connecting them as you go, and then making a little low spot here. This is what your profile should have looked like. Okay? And so for the line A to B, I noticed probably the number one thing, if you got this right, but most of it was right, you might have just gotten partial credit, was because you did this with the line over here. So I'm going to show you why it's this way underneath and not over top. Okay, so looking at this section, you're drawing your profile from A to B. And so this is your last dot right here where B is. So this is the 2900 line. The line before it is 28. So this section of line from here to here is exactly what this is. Notice they're the same distance apart. So a lot of people did this weird little hill thing at the bottom of it. So how you would know to go down versus up would be to look at the 29 and 28. So this line goes between 29 and 28. You can see that it's not above it, it's below it. It's between these two numbers. So when you draw your line in, it should also be between the 29 and 28, not the 29 and the 3000. So that's how you would know to make sure it goes in between these two lines and not in between these two lines. Okay? And again, I gave you partial credit. If you just messed up that part, it just took 1 point off. On the regions, the whole thing would have been wrong. Okay, so that's one whole question you wouldn't have got credit for, which is why the regions is difficult. Questions on drawing the profile? Okay, so the second part to this was calculating the gradient between points X and Y. So you need to calculate this gradient, not this gradient, this gradient. So the value at X is 3,500. Y is 3,000. And the distance between them, using the scale at the bottom and using your paper to kind of measure that, you should have found to be, I got 1.7 miles. Now, you didn't get exactly 1.7, but instead you did 1.6 or 1.8. I also accepted that. Okay, so there was a range of acceptable answers for this question. So then you would do your 3,500 minus 3,000 and divide by your distance. So 1.6, 1.7, or 1.8. Okay, I did 1.7, so I got the number right in the middle. Your answer could have been anything in between 277.8 and 312.5. Okay, as your answer for this. Anything in between there would have been correct for full points, because there was different options for the distance. Okay. I tried to be generous with the range I accepted for miles. But try your best to be as exact as you can be, using a nice sharp pencil to get the distance on the scale. Yes?
On the regions, do you have to be actually exact when they do?
They give you ranges like this as well. Yeah, which is nice of them. Yeah, you'll get a range for acceptable values for a question like this. Not always, but for this type of question, they would also give you a range. I try to keep my grading right in line with what the Regents does, except in points like this where I want to be more generous. My tests, the questions are worth more than the Regents' questions are for each one, so I compensate by that by giving you partial credit. Okay? Questions on this or this? Okay, moving on. The back page. So, on the back you had to calculate volume, which I was surprised that a couple people had trouble with still. It may have been because it was just so long ago, which is fine, but just remember you're still responsible for knowing the things that I taught you at the very beginning of the year in June. So, this was a density question, but they wanted you to figure out the volume when they give you the mass, and they also give you a density. Okay, so density, mass, volume. So if I need to solve for volume, I cover up the V, and I know that volume is equal to mass over density. So they're talking about a spinel crystal, so you know you're using this column, and the density you're using is 3.8. So there's a lot of steps to this. It wasn't just get density, it was use this confusing chart. Read these weird gemstones. Look at all this extra information they give you don't need, but you gotta like hone in on the information you do need. This is what makes this a Regents question. Okay, so volume is equal to 9.5 grams, which they give you in the question, divided by 3.8. This is grams per centimeters cubed. And so your correct answer should have been 2.5 centimeters cubed for this. And no range of acceptable answers. That's just the right answer. That's it. Questions on this before we get to mapping? Okay, so let's talk about this map. This is where like a lot of the information came from, was using this map. And before we get to it, I'm just going to draw in what was on yours. So this is H, this is G, and then F is right here. Okay. So 24, what is the elevation of point A, the dot? So point A is in a depression. They even tell you that here at the bottom. They just tell you that this is a depression. So if your contour interval is 10 meters, this is 20. At A, it would be 10 meters. Okay? So you're counting down by 10. So 10 meters for that one. For 25, the maximum possible elevation at point F. So this outside line is 50. So you're counting up. This would be 60. And then the highest line on there is 70. Okay, so that's what each of these are. 60. Let me zoom in even more. I feel like I need to see this better. There we go. Yeah, 60. And then this line here is 70. So if you want to know what the maximum elevation at F would be, you have to remember the formula I gave you in your notes. So the next highest line would be 80. Okay, so 60, 70. If we drew another circle, there would be 80 minus 1. The answer would be 79. That was what I was looking for. Yeah. Yeah. 26. What is the direction of stream flow between G and H? So here's G and H. I would have drawn in north, south, east, and west on the map. And using the contour lines, I can detect the direction of stream flow and also looking at the values of the lines. So if this is the ocean, this value is 0. Okay? And then you have 10, 20, 30. This would be 40. You have this is like 50 right here, just about. And as you go down, this goes down to 0. The value of this line is 0. So I know the stream is going this way, okay, from east toward the west. So it's going west. And the reason I know this is two things. One way is I can look at the direction the contour lines are pointing. They're all pointing toward higher elevations. Or I can just know that streams are going to go toward lower elevations, starting at 50 and going down 40, 30, 20, 10, and then 0 out to the ocean. Okay, so that was questions 26 and 27. Okay, last two have to do with the steepness. Okay, so the steepest area on the map is between M and N. And how do I know that? What is different about M and N than any other place on the map compared to all these other locations? Cole, what do you think? Yep, these are where the contour lines are nice and packed in close together, and that's how I know it's very steep in this location. Okay, exactly. And yeah, 30, everybody did the isotherms well, so I don't think I really need to go over that. If you missed one, or maybe you didn't let them go off the page, I maybe took a point off. If you did it completely wrong, then I just marked the whole thing wrong. But I think for the most part, people got credit for this one. And the answer to the bonus was worms. Inchworm, bookworm, and earthworm are all worms. Yeah.
So the contour line, the further you go in, it shows elevation unless it says depression?
Yeah, so if you wanted to like look between two lines, you could determine, you couldn't say exactly what the value was in here, but you would assume as you move from one line to the next that you're increasing in elevation. If you see circles within circles, it's going up. Except for a depression.
So it would say it though.
Yeah, it would have to note it with these little like lines on there. This one actually tells you, but they don't have to. That's something you should know. Exactly. Yep. Any other questions on the test? Okay, if you feel like there's a discrepancy in how I graded it, if you think you should have gotten something different, just circle what you think the problem is, leave me a little note and put it on the desk and I'll look at it again. I am a human and I do make mistakes, quite often actually. Okay, so I'm happy if you check up on me. Okay. All right, so let's move on to new stuff. Let's see what time it is. Okay, perfect. So I'm gonna give you your new notes for tomorrow, just so you have them. But we're not gonna start any notes today. So if you wanna take these, let's do this first. Take a second and clear out your binders. So take all the material out. That's old notes and quizzes and homework assignments, and just remove those from your binder. They don't need to stay in there. Put them in a nice pile, and you take the pile home, and you leave it there until it's time to study for the Regents. But that way you have a nice clear binder to take out. Okay, and so if you're following along at home, you can do the same thing. I'm just going to give out notes, and then we're going to get started with lab